In this video, we're talking all about order of operations and how to use them. So for this video, we're going to be using the acronym PEMDAS. Please excuse my dear Aunt Sally is one of the ways that students have been taught to remember this acronym, but the P stands for parentheses, E is for exponents, M is for multiplication, D is for division, A is for addition, and S is for subtraction. There are some other acronyms that are used around the world. I'm based in the US, and the PEMDAS is the one that we typically use here, but I will go over some of these other acronyms at the end of the video, but all of these different letters stand for the same thing. They're just different words for the same thing. But let's go ahead and get into some examples. All right, we're starting off with a couple of pretty basic problems here, but if you'll notice, each of these have the same numbers in them. The only difference is that this first problem has parentheses and the second problem does not. So I just wanted to show how that can really make a difference with the order of operation. All right, so let's start off by just going down our list of order of operations. The first one is P for parentheses. We do have a set of parentheses in this first problem, so let's go ahead and solve that first. So we're going to go ahead and add 6 plus 1 is 7. And then we're going to just drop down everything else that we haven't used. Now the sign between the 2 and the 7, since we don't see anything here between the 2 and the set of parentheses, that is always going to mean multiplication. So I'm just going to go ahead and write in a multiplication symbol there. All right, so now let's go ahead and continue solving. We don't have any more parentheses, no exponents, but we do have multiplication. In fact, that's all that we have. Now the rule with multiplication is that you can multiply these in any order that you'd like. Since we just have multiplication, you can multiply all three together at once. Let's just do it one at a time. So 3 times 2 is 6, and then I'm going to drop down the times 7, and then 6 times 7 is 42. So we get an answer of 42 for this first problem. Let's see what this looks like with the second problem without any parentheses. So no parentheses, no exponents, but we do have multiplication. So I'm going to start from left to right and just do 3 times 2. That gives us 6. Drop everything else down that we haven't used yet. All right, and now I'm looking at this as a new problem, and I see multiplication and addition. So I'm going to do the multiplication first. So 6 times 6 is 36. Drop down the plus 1. And then our last operation, 36 plus 1 gives us 37. So as you can see, we got two very different answers for each of these problems. They each had the same numbers in them, but the order of operations really does make a difference. All right, we've got another example here. This one is a little bit more complex, so let's get into it with our order of operations and see what we should do first. Starting off with parentheses, I do see that we have a set of parentheses, but inside that set of parentheses are two different operations. So those operations are division and multiplication. So as you can see over here in my notes, I do have an arrow going from multiplication and division, and that is because division can be done before multiplication if it comes first when reading from left to right. So as we read this problem from left to right, we see this division sign before we see the multiplication sign. And that is a common mistake that I see a lot of students making when I'm working with students on order of operation. Because we have this acronym PEMDAS, it's a great way to help us to remember the order of operations, but it can get confusing because M is listed before D. Sometimes students automatically think that the multiplication has to come first before division, but the division can come first if it is first from left to right when we're reading this. So let's go ahead and perform that division operation. 18 divided by 6 is 3, and then I'm dropping everything else down. Since I still have that multiplication operation that's inside the parentheses, I'm going to keep my parentheses. I can't get rid of the parentheses quite yet. And I'm just dropping everything else down that I haven't used yet. All right, so we do still have that parentheses, so we're going to go ahead and perform that multiplication next. So 3 times 2 is 6. At this point, I can get rid of the parentheses, but I don't want to forget that that exponent of 2 is there. And then let's just drop everything else down. One thing that I want to point out here, we don't see any parentheses written. However, whenever you have an operation in the numerator or the denominator of a fraction, we need to go ahead and treat that as if it is in parentheses. So I'm going to go ahead and do this 10 minus 1 next. Although we don't have the parentheses written there, it's sort of an understood parentheses that quantity, that 10 minus 1, has to be performed first before we complete the rest of the problem. So let's go ahead and do that. So 10 minus 1 is 9, and then dropping everything else down. All right, so parentheses, we're good with that because now all we have is a single number in the numerator and the denominator of our fraction. Exponents, we do have an exponent. So remember that this isn't 6 times 2. This is 6 times itself. It's 2 6s multiplied together is 36. And then dropping everything else down. All right, now let's see what we have left. We have an addition sign, but also we have a fraction, and a fraction is just another way of writing a division problem. Because I know that 9 can be divided by 3 evenly, I'm going to go ahead and perform this division just as if it was written like this, 9 divided by 3. These two are the same thing. If this fraction didn't come out evenly to a whole number, you would want to simplify that and then go ahead and add or subtract or whatever other operation there is. But let's go ahead and do that division because division does come before any addition or subtraction. So 9 divided by 3 is 3. We're going to drop everything else down. And then our last step is this addition. So 3 plus 36 gives us 39. Let's go ahead with one more example. All right, so let's start at the top here. Parentheses. I do see a set of parentheses right there. 2 plus 1 is 3. So I'm going to go ahead and write that and drop everything else down. Make sure that everything is in the right order here. Again, we don't have any parentheses written, but we do have an operation in the denominator of our fraction. So we're going to treat that as if it is a set of parentheses. So let's go ahead and do that. 5 minus 3 is 2. And then we'll just drop everything else down. Okay, so now we don't have any more parentheses. Again, we just have a whole number in each the numerator and denominator. So we're going to move on to exponents. We do have an exponent, so 4 squared, so that's 4 times 4 is 16. Write everything else down that we haven't done yet. All right, now we're going to look at this as a new problem. What do we have? I see subtraction, I see addition, and that fraction is, again, division. So we're going to do that division first. Division comes before any addition, subtraction. So 6 divided by 2 gives us 3. Write everything else down. All right, now we've got subtraction and addition. So just like we talked about with the multiplication and division, addition and subtraction can also be switched depending on how they appear in the problem. As we're reading from left to right, I do see that subtraction before the addition. So I want to perform that subtraction first. So 16 minus 5 gives us 11, dropping down the plus 3. And then our last operation, 11 plus 3, gives us 14. So we wind up with 14 for our answer. All right, so I promised you that we would talk a little bit more about these other acronyms that you might see. Actually, if you know some of these other acronyms, if you're somewhere else in the world besides the US, then please let me know in the comments which of these you've seen, or if you have another one that you've seen that I don't have listed here. So as I've said, PEMDAS, that's the one that we typically use here in the US, but I've also seen GEMDAS, BEDMAS, BODMAS, and PEMDAS. So something to notice is that in all of these, the AS, the addition and subtraction, is the same at the end. The other thing to notice is that the M and the D are both here. Some of them have the division listed before the multiplication, some of them multiplication before the division, but as we've discussed, they can go in different orders depending on where they show up in the problem. So with the exponents, we know that E stands for exponents, as we've talked about before. The O stands for either order, or I've also seen it as the word of, as in the power of, right? So we could take this example here. 2 is being raised to the power of 3, or the order of 3. Same concept, just different words for the same operation. Here for the first letter of these, we have this P stands for parentheses, just like we use in PEMDAS. The B stands for brackets. And then the G stands for groups. So again, just different words for the same concept, for the same operation. So we have the curved lines that we normally see as parentheses. Then we also have brackets that look like this. And then I've also seen like the curly brackets, right? So all of these just mean the same thing. We're grouping some operations together, and those need to be first. Just different words meaning the same thing. Thanks so much for watching. I hope that this order of operations video was helpful for you. If it was helpful, I would really appreciate a like and maybe even a subscribe. That really does help me to continue to make these math videos for you. Let me know in the comments what you thought and if there are any other skills that you would like to see, and I'll see you next time.